Hi everyone. So today I talk about some problems about homework assignment 2 so that you get ready for your test. The first question was I asked you about a speed in velocity from meters per second and what it is in kilometers per hour. Okay, so in the question was 3, I use 5 here. So stairs method, meters to kilometers, division, seconds to hours, another division. So let's just do the divisions. 5 divided by a factor of 1,000 meters, kilometers, factor of 1,000 over now seconds. Seconds to hours, a factor of 3,600. You may now ask why I'm having, this is the problematic part for most of you guys. Let's elaborate on that. Do you agree that I have 5 meters per second? So let's just write it out. 5 meters per 1 second, right? That means 5 meters per second. So now just do the math. Meters to kilometers. Divide that by 1,000 right there in the numerator. 1 second, 2 hours, divide that by 3,600. So 1, divide that 1 second, divide that by 3,600. And there you go. So that's it. So now 5 times 3,600 over 1,000 times 1, and then that turns out to be, these two cancel out, this cancels out, that becomes 18 kilometers per hour. So if you go with 5 meters per second, namely if you in every single second you go 5 meters, it's the same as you say in 1 hour I go 18 kilometers. So this is the stairs method. Some people don't like this. I'll go the other way and see, we get the same result of 18 kilometers an hour. So we go 5 meters per second. You try to cancel meters and seconds here in the numerator and denominator and try to generate kilometers and hours upstairs and downstairs. So 1 meter is 1,000th of a kilometer, and 1 second is 1/3,600th of hours. So let's just do the math. 5 times this gives you 5 over 1,000 over, so this is 1 over 3,600, and 5 times this over 1 times 1,000. So sure, of course I get the same result. Kilometers an hour, and as you can see, seconds, meters, kilometers per hour. Watch this. Good. Okay, so that's the first one. So if it is division, and I know division is kind of like a little bit shakier, but just try to get used to it. It's essentially the same as multiplication, but you just have to be a little bit more careful about division because it's kind of a little bit more confusing, I found. Also, you have a car that travels from this much to that much in this many minutes, and then there is another car who goes from this much to that much distance in that many distance. Calculate the average speed of each car. So average speed is the distance over time. So if the distance is, let's say, 5 miles, and then this 5 miles is covered in 5 minutes, then it would be 1 mile per minute. Don't worry if you're not asked about saying anything in meters per second, just don't bother. 1 mile per minute, that's okay. And you do the same thing for the second car, and then you just compare the numbers. The other question was asking you, about the average speed, again, just like the second one. The fourth question asks you, a cruise ship covers a distance of 80 miles during the, watch that lasts from midnight to shore. That's easy. So you are covering up 80 miles from midnight to 8 a.m. So that's 8 hours. So you go 10 miles an hour, and then obviously when it is 4 a.m. and you're in like midway through the motion, the speed is constant, and because it's constant, it's going to be 10 miles an hour throughout the whole journey. Now, fifth question. If a person walks at a speed of 3 miles an hour for 4 hours, how many miles? Of course. So the speed is distance over time. So if I go 3 miles per hour and I do this in 4 hours, then my distance would be 3 times 4, 12 miles, right? That's easy. Number 6 tells you if you throw a ball with a vertical speed of 50 meters per second, how long will it take to reach its maximum height? I like that question. Now it involves Earth, and whenever we see Earth, we know that we have accelerating motion. So we have Earth, and this is question number 6. So we have Earth. We are throwing the ball with 50 meters per second. Now I do another one with, let's say, 30. So if I'm throwing a ball with 30 meters per second, then after 1 second becomes 2 meters per second. After second becomes 10 meters per second. Third second, it stops. And we know where it stops is its maximum height, because right after that it comes down back to Earth. Right? So for 30 meters per second velocity, it takes 3 seconds to get its maximum height. Number 7, if a car changes speed from 50 miles to 58 in 2 minutes, calculate its average acceleration. Sure. So if you are going from 1 miles per hour to another number for miles per hour, then in specific amount of time, let's say V1 is, let's say, 30 miles per hour, V2 is 36 miles per hour, and I do this change during 2 minutes. Now, average acceleration, change in velocity over time, which is 36 minus 30 miles per hour over 2 minutes, right? This is minute. So average acceleration would be 6 miles per hour over 2 minutes, and that gives me 3 miles per hour per minute. You could convert minute into hours if you like. However, if you're not asked about it, don't bother. So let me just do that for you so that you get a practice on how you convert. See, we got A equals what? 3 miles per hour over 1 minute. Okay, so if I want to express this number in terms of miles per hour, which becomes miles per hour squared, then what I will do is that I say, okay, I'm not changing the numerator, but I'm going from minutes to hours. Minutes to hours is another division, divided by 60 now. So I go 3, I'm not changing the numerator. This is a denominator of 1, right? So 1 divided that by 60. Therefore, 3 over 1 over 60. How would you do this? You would go 3 over 1. This is this. 1 over 60. Three times 60 over 1 times 1. That gives you 180 miles per hour squared. Okay? So it's either 3 miles per hour per minute, or if you want to describe it in miles per hour, then it's 180. Okay? And this is how you do it.